Have you ever stopped to think about how your smartwatch instantly buzzes with a new text message? Or how you can stream a movie on your laptop from a server that's thousands of miles away? Well, it's not magic. It's all thanks to a complex web of interconnected networks. Today, we're going to pull back the curtain on that invisible web that basically powers our entire digital lives. Really, it all comes down to this one simple question. How does all our information get from point A to point B? I mean, everything. From a quick text to your friend all the way to streaming a 4K movie from a server halfway across the world. So let's start peeling back the layers on that very question. Just think about all the devices you've used today. Your phone, your wireless headphones, your smart speaker, maybe even your car. We are absolutely surrounded by this sea of connected gadgets. It's this incredible, complex dance of data. And to make it all work together seamlessly, we need different types of networks. And each one has its own very special job to do. So here's our game plan for this explainer. We're going to start small, really small, with the network that exists right around you, your personal space. Then we'll zoom out to the network in your home or your office. And from there, we'll zoom out again to cover the entire globe. And to wrap it all up, we'll get into the nitty-gritty and look at the actual physical wires that make it all happen in a head-to-head showdown. Okay, first up, let's talk about the most intimate network of them all, the Personal Area Network, or PAN. You can just think of this as your own little personal tech bubble. You know, you actually use a PAN every single day, and you probably don't even think about it. That moment when your wireless earbuds instantly pair with your phone? Yep, that's a PAN. Or when your fitness tracker syncs your steps to your laptop? That's a PAN too. It's your own private, tiny little network.
And the real beauty of a PAN is just how simple it is. It's got a really short range, which means you get less interference, and a much more stable connection for your personal gear. It's a network that's literally built for one person, and it's all powered by technologies we know and love, like Bluetooth, which are designed specifically for these close, personal connections.
Okay, so let's zoom out one level. Now we're at the Local Area Network, or LAN. This is the workhorse network that powers your home, your school, or your office. It's the central hub for all your devices in one place. Now, this might look a little complicated, but it's pretty much the setup in most of our homes. The internet signal comes into the building, it hits your router, and that little box acts like a digital traffic cop. It directs all the data to your different devices, whether they're plugged in with a cable or connected over Wi-Fi. The real magic of a LAN is its speed. It's the reason you can stream a high-definition movie from your computer to your smart TV without any of that annoying buffering. It's a fast, private network for your own space. And you know what the best part is? It's actually pretty affordable to set up. All right, it's time for the final zoom out. We've gone from your personal bubble to your local hub, and now we've arrived at the big one, the Wide Area Network, or WAN. This is the network that connects all of us on a truly global scale.
A WAN is basically what connects your local network, your LAN, to the rest of the world. It's really a network of networks, and the biggest, most famous one of all is, of course, the internet. It's the digital superhighway that lets you send an email to someone on the other side of the planet in just a split second. Now, connecting the entire planet is, well, it's a massive undertaking. We're talking about thousands upon thousands of miles of cables running under the oceans. And we've got satellites orbiting the Earth, beaming signals down. It's an incredibly complex and expensive system. But it's the invisible infrastructure that holds our entire modern world together. So we've talked about the ideas of PAN, LAN, and WAN, but how does the data physically travel from one place to another? Let's get down to the physical backbone of it all, the actual cables that carry all that information. So how does the internet physically get to your house? Well, it travels through one of these two types of cables. Over on the left, you've got the old school, traditional copper wires, and on the right, the super modern, futuristic fiber optic cables. Now, they both get the job done, but as we're about to see, they are worlds apart in how they work. So let's do it. Let's put them head-to-head in a showdown. We'll see how they stack up against each other in terms of performance, cost, and even security. Let's start with the reigning champion, good old copper wire. I mean, this is the technology that's been connecting us for over 100 years. It's simple, it's reliable, and it works by sending little electrical pulses down a metal wire, almost like a super fast digital Morse code. Copper's biggest selling points have always been its cost and convenience. It's relatively cheap, it's really durable, and it's pretty easy to install.
Plus, because it's been around for so long, it works with a massive range of existing network equipment. That makes it a super versatile and cost-effective choice for a lot of situations. But copper definitely has its weaknesses. It just can't carry as much data, which for you means slower internet speeds. The signal can also get weaker or fuzzy over long distances, or even if there's other electrical stuff nearby. And since it's an electrical signal, it's actually easier for someone to listen in, which is a pretty big security concern these days. And now for the challenger, fiber optic cable. Instead of sending electricity down a wire, fiber optics send pulses of light down a teeny, tiny strand of glass. We are literally sending information at the speed of light. And the difference is just it's night and day. Fiber is lightning fast, it's got enough bandwidth for all your devices and then some. The signal stays perfectly strong over huge distances, it's totally immune to interference, and it's way more secure. Honestly, it's the future of the internet, and it's here today. So if fiber is so great, you're probably asking, why aren't we all using it? Well, the short answer is money. Fiber is more expensive to make and to install, and it's a lot more fragile than sturdy old copper. It also requires a whole new set of equipment, which means a pretty big investment for internet companies to make that switch. When you boil it all down, this right here is the fundamental difference. On the left, fiber optics use a glass core that's as thin as a human hair to guide a ray of light. On the right, copper uses a bundle of metal wires to conduct electricity. It's light versus electricity, and that one single difference changes absolutely everything. So that brings us to our final thought for today. From the tiny pan in your pocket to the global WAN connecting continents, it all comes down to a physical connection. And as our demand for faster speeds, more data, and better security just continues to explode, which one of these technologies, the reliable old workhorse or the high-speed challenger, do you think will ultimately wire our future?